Thin layer chromatography for separating and identifying amino acids. The theoretical concepts behind this chemical principle. All types of chromatography work on the same principles of separation and absorption, as different compounds distribute themselves to varying extents between different phases or separable portions of matter. Thin layer chromatography is separated on the basis of polarity and consists of a solid silica stationary phase, known as the thin layer chromatography plate, and a liquid mobile phase, which is a solvent. The solvent consists of propanol, acetic acid, and water in a 4:1:1 ratio. As the stationary silica phase is polar and the solvent is nonpolar, the polar components of the enolate, the amino acids, will adhere to the silica tightly and thus travel slowly up the plate, while the less polar or nonpolar components will not adhere that strongly to the silica and travel up the plate relatively fast with the solvent. All amino acids have the same structure, and it is the side chain group that determines its identity and polarity. They can be classified into 4 groups based on their structure: nonpolar, polar neutral, acidic, and basic. And within these groups, there are different levels, strengths of their classification depending on their side group. For example, alanine and leucine are both nonpolar amino acids. But leucine is more nonpolar than alanine, as it has a larger aliphatic hydrocarbon side chain. Basically, the less polar, the greater the distance traveled, and therefore this differentiation allows the amino acids not only to be separated, but to be identified. The experimental procedure to demonstrate this topic of separating and identifying amino acids. The thin layer chromatography plate was prepared and the amino acids were spotted along the bottom of the TLC plate. This was placed into a beaker with the solvent at the bottom. A watch glass was placed on top to make it a closed system to keep equilibrium. Once the solvent had travelled 3/4 of the way up the TLC, it was taken out and the solvent front was marked. Then the plate was sprayed with ninhydrin solution in the fume hood and developed by heating with a hairdryer or oven. To actually analyze the results, the retention front value is calculated. The difference between the solvent front and origin are measured and used to calculate the RF value, which is the ratio of the distance the spot travelled to the distance the solvent travelled. Substances with a similar RF value therefore must have a similar polarity due to the distance they travelled. So to identify amino acids, the RF value is compared. For all lab work, closed-in shoes, a lab coat, safety glasses and gloves should be worn. There are numerous chemicals involved in this experiment, so the correct PPE must be worn. Chemicals must be handled carefully and disposed of safely. Acetic acid is highly corrosive and flammable, therefore can cause skin burns and eye damage. Propanol is also an irritant, flammable, corrosive, and can cause drowsiness. Ninhydrin solution is an irritant, and lastly, most amino acids don't meet GHS hazard criteria, therefore they aren't hazardous. However, some are irritants, such as tyrosine and phenylalanine, and so care needs to be taken when handling these amino acids. Glassware must be handled carefully and if broken, disposed into the appropriate container. When using a hot plate, make sure area is tidy and use appropriate materials. Thin layer chromatography has real-world importance in not only a biomedical setting but also across numerous industries. It can be used for the biochemical analysis of blood, urine, and body fluids to isolate or separate the metabolites in the sample, to determine the purity of a sample by comparing the sample and authentic sample, and to see if a reaction is complete. Thin layer chromatography can also be used in the food industry to separate and identify colors, sweetening agent, and preservatives, as well as the cosmetic industry. Lastly, it can be used in the pharmaceutical industry to separate multi-component pharmaceutical formulations and to test medicines such as anesthetics and antihistamines. Therefore, separating and identifying amino acids through thin layer chromatography can be explored by identifying the interactions between chemical concepts and real-life applications. Thank you.